All right. Okay, Jerry the Plater here. I think we can call this Electroforming 101. So what we have here are two copper electroforms. All of the copper that you see in the picture, in the video, that was electroplated out of an acid copper plating tank system that we have, starting out with an aluminum mandrel. If you look here at the end of the piece, you can see the aluminum down the middle, which has been drilled out. That mandrel will be removed. That's the next step in the finishing of this part. But you see the aluminum mandrel, and then around it there's a ring of copper. It stands out from the brass quite obviously. So that copper was actually electroplated onto the aluminum mandrel a week or two ago using our copper electroforming system that we have here at the CDL. So after we did the electroforming on this piece, forming up the bulk copper that actually forms the body of this waveguide component. This is a circular to square waveguide transition. And this is a square to square with a 45-degree twist in it. Part of the phase shifting, phase separation system that we use. So again, all this copper was actually electroplated copper that came out of the acid copper plating solution. Took about 6 or 7 days to actually do the plating to build up about 0.2 inches of wall thickness for the component. So after we do the electroforming part of this job, these parts then went back over to the machine shop in Greenbank, West Virginia. And the machinist there cut these two pieces off to length. Looks to me like they did a fair bit of machining on the copper itself. They've turned that down into a nice cylinder. Definitely have done some turning over in this area, cleaning up the part, making it more symmetrical. Also destroying the nice shine of the bright copper, which was there initially after plating. Our copper plating system deposits a very bright, shiny copper, quite beautiful. But they've done machining on this, and I think they've probably done a shot peening or a sandblasting operation and dulled the finish a good bit. So we don't really have the brilliant acid copper that we did when these parts went over to Greenbank. But what we do have now are two waveguide components that are much closer to being finished parts. So they took these pieces, they did machining on the ends, they machined down and created a shoulder at either end. Probably cut off about a ½ inch on both ends of these two to get it down to the desired finish length. So then they do the machining and they create that thickness of copper that you can see in here. They create that thickness of copper. And then they make the brass flange, which is then put into place and soldered. I think they're probably using a solder called Eutectic 157. And they get a very nice, even solder joint all the way around the perimeter of the copper electroform. And where they get it perfect, they get a very tight joint on this end too, without any gaps. I think one of the parts here one of the pieces here you do see some gaps on the finished end, but that's irrelevant. It doesn't affect the performance of the finished component. So the next step in finishing now is we'll be taking both of these parts and we'll go into the gold plating tank here in the lab. And we'll plate up a fairly heavy thickness of gold onto this guy, probably on the order of 100 to 150 microinches of gold. That gold is then somewhat a barrier layer when we go into the final production step. And then our final step, after we've protected the part with gold, put the finished gold plate on too. That becomes the finished gold plate, more or less. Then we're going to go into a solution of sodium hydroxide, and it'll take probably 24 hours. But we'll chemically dissolve the aluminum mandrel, what's left of the aluminum mandrel. They've nicely machined out You see our reflection there. That's a beautiful bright finish on the flange, on the end of the piece. You can tell they've probably worked on 2000 grit paper, or maybe even finer, to get a fine shiny finish on the end. So then we're going to go into sodium hydroxide. Since they've been able to drill through all the way through the mandrel, our sodium hydroxide will be able to flow through the aluminum mandrel, and we'll be etching away from both the ends, but we'll also be etching from the exposed surface inside that hole. So a piece like this, you're typically looking at about 24 hours of etching time to remove the mandrel. You know, maybe a little bit more on this piece because of the length of it. There's more copper or more aluminum there that needs to be etched away. But again, the fact that we've got a hole going all the way through the part speeds things up tremendously. You've got that much more surface area for the etchant to go to work on. And a little bit unusual, typically when we get a part like this back from the machine shops, they'll have already put the tapped holes into the flange. I think in this case and certainly they could have located, I think, off of these sharp corners. There shouldn't be any problem doing that. But I think they decided they would rather have the mandrel etched out. Maybe they're going to insert sort of a drilling guide, possibly, into the finished part. You know, a plug of machine metal that could fit down inside with a drill guide that's attached to locate the holes. If not a drill guide, at least a location guide. Anyhow, a little bit surprising that the flange holes are not in place already, but that's certainly a legitimate machinist choice, you know, as to when they want to put those holes in. So that's it for this stage of finishing copper electroforms. So Jerry the Plater signing off. Bye-bye.